Hello, my name is Mark Carlson, and I'm giving a talk today on managing Ethernet attached drives using Swordfish. So storage networks are evolving, have evolved from the days when everything was direct attached storage into the area of storage area networks where multiple hosts are sharing storage. This allows you to avoid those silos of storage and enables storage efficiencies. Some examples include fiber channel and iSCSI storage networks as well. But traditionally, this requires a storage controller to front the actual storage drives. In the hyperscale customers, they've typically been using direct attached storage and avoiding a separate network that requires separate network administrators. But they have plenty of software developers that make their own software that makes scaling hyperscale nodes a solution. Now the industry is moving to NVMe and NVMe over Fabrics technologies. You can create a SAN with it, or you can put it on your regular LAN. So now systems and devices on native Ethernet as a storage network. Initially, Ethernet is just a transport. Endpoints performed all the storage services, such as iSCSI. But use of Ethernet matured and specialized protocols arose. Key value is one way to access data in a mainframe context. Object protocol to access massive amounts of unstructured data. Now we've got NVMe over Ethernet, which is storage in a queuing paradigm. So this is high performance, it's very low latency. There's few or no processing block edges on the way to I/O. It's no longer gated by the transaction paradigm, which is waiting for an acknowledgement necessarily. So the next step is logically NVMe over Ethernet to the drive. That removes a storage controller processing bottleneck as well. So NVMe over Fabrics is evolving still at NVMe Express organization. And it allows sharing NVMe-based storage across the network. So you can get better utilization, capacity, rack space, power, better scalability, management's all in one place, and fault isolation as well. So NVMe-oF has been refactored now by the NVMe organization, and it supports TCP/IP as well as Ethernet, InfiniBand, and fiber channel. And we're starting to see products now in the market from most major storage vendors on this. So the traditional way is to terminate the NVMe-oF connection and use PCIe-based SSDs internally or on the back end. They're behind an array or even a JBOF controller. And this does have performance limits. As SSD performance and capacity increases, you need more scalable compute resources as well in that controller. So there's a cost, a CPU, there's RNICs, there's switches, and the memory have to be bought when you buy the system, even if you don't fill it with drives. So the scaling unit is quite large. With NVMe-oF Ethernet SSDs, the only thing that front ends the drives is an Ethernet switch. And that doesn't need any CPU to scale more and more drives. At some point, you run out of space in your enclosure, you buy another enclosure, which is fairly inexpensive, and then continue adding drives as you need to add more capacity. So does this make each drive more expensive? Maybe initially, but now the customer can buy their controller incrementally, if you will, so that they're not paying up front for a huge controller, even if their actual enclosure isn't full. So SSD throughput is increasing faster than the network bandwidth. SSD throughput will triple, whereas network speed only doubles. And so in order to eliminate this, we need to have the SSDs do the actual networking. There's different eSSDs designs today, and we'll be supporting different protocols. Rocky is one of the NVMe-oF transports, but now there's also a TCP transport. And as these sort of controllers get further integrated into the drive, they can be further integrated into the system on a chip controller in the drive. What's on the right here is the pinout for the 8639 connector for Ethernet drives. And you'll notice that we use the same pins as PCIe, because we know those are going to go all the way up to Gen 5 or Gen 6. So use case initially is maybe sitting behind a controller, a current existing controller, but it allows that controller to manage many more drives and scale much further than a PCI switch does. So putting Ethernet on those drives allows that front-end controller to have a much larger pool of available storage devices. It really scales all the way to a rack, at least, with that back-end Ethernet network. And then there's the disaggregated storage, where there is no array controller. There is really just a switch. Any kind of data services you might want to be done can be done on the host. There's lots of software-defined storage applications that can be used in this situation. And the Ethernet drives will be able to talk to multiple hosts in a secure manner. So we've come up with a native NVMe-oF drive specification. We released that last year. It has that pinout, as I mentioned, also for the EDSFF connector, which is SFFTA 1002. And we have pinouts for that, which are now part of the SFF specifications. Management, it would be through Ethernet TCP for data center-wide management. And what that looks like is you want to be able to scale out the orchestration of tens of thousands of drives in a data center by using a RESTful API such as DMTF's Redfish. SNIA extends the Redfish model and protocol to better take advantage of storage. And the principle is that each element reports its own management information. You don't have to scale by having a number and bigger and bigger management agent platforms. So when you get back a JSON of that drive, you can follow it directly to maybe the enclosure or to the power supply or to the switch. And they each then also supply their own information. So we have an NVMe-oF drive interoperability profile. What an interoperability profile is a profile of the entire forest of trees down to just the trees you need to manage an NVMe drive. So we push those new models up through Swordfish contributions. We published the interoperability profile at DMTF. We have a whole conformance test program that will allow you to test your drive to make sure it meets the profile. And there's a map, if you will, from NVMe and NVMe properties and actions to the actual Swordfish model. And that's documented in the Swordfish NVMe model overview and mapping guide. So we've actually been doing this work in conjunction with both DMTF and NVMe and provide this base manageability for NVMe devices. So we can manage individual and aggregate devices and environments at scale and provide this clear map. And we'll be extending that over time. So Redfish and Swordfish use the available low-level transports to get device transport-specific information into the common models. NVMe-MI can be used as a low-level to get the information into the high-level management environment as an out-of-bound access mechanism when appropriate. So here's some of the major NVMe objects mapped to Redfish. NVMe subsystem, NVMe controllers. There's IO, admin, and discovery controllers, namespaces, endurance groups, NVM sets, and NVM domains all have associated objects in the Redfish Swordfish model. Here, graphically, we show this model with entity diagrams as well. So for the subsystem, it maps to the typical Swordfish storage object. For NVMe IO controller, it maps to the Swordfish controller. A namespace maps to a volume. Pretty simple. And this is an instance view. When you create instances of these objects, this is what you might see. And because it is an Ethernet attached, there's a network adapter, there's a port, there's network device functions, etc. So who is developing this? Well, these are the companies as of February 2020 that were participation in DMTF, SNEER, or even both. And so that shows a broad support of this effort and continuing to improve and mature both of these specs for the latest technologies that are coming out. So for more information on Swordfish, on Redfish, on Open Fabrics Management Framework, or on NVMe Express, these links you can get out of the PDF that is up on the website available for your download. So thank you for attending, and please take a moment to rate this section on the website. Thank you very much.